Well, hello guys, here Mr. G with another question. This time we're going to be working for the grade 10s, and this one is related to motion in one dimension. It was question 3 done in the Eastern Cape province in 2022. I'm going to leave the question in the description below so you can answer the question before watching the video. But subscribe for the channel and like the video before we answer it. The Banyana-banyana soccer team members were busy warming up for the match against Morocco during a Afcon played in Algeria. Below is a diagram that represents the measurement of the soccer field using by 3 players, Dlamani, Biyana and Jane. So you see the soccer field there, and then is the questions that follow. Define the term distance. And this is an easy definition. Distance is the total path length traveled. That is what we have for distance, and is 2 easy marks. Dlamani started at point A, jogged to position E, and back to A in 1 minute. Determine the total distance covered by Dlamani. So Dlamani, all it does is it went from A to E, which is 100 meters, and then went back there, it is another 100 meters. So let's make this one here so you can see this is what it does. And that one is 100 to E and 100 to A. So the total distance will be equal to 100 plus 100, and this is equal to 200 meters. Now you need to remember that distance is a scalar quantity. So we're going to write it here. Distance is a scalar, which means no direction. So you don't have to give a direction for a distance. Alright, so it's 200 meters, guys, and that is quite simple. And then if you write 200 meters, you will get 2 marks. You don't have to even show that it's 100 plus 100. We go to 3.2.2. Calculate the Dlamani's average speed. Now, what you need to know? You need to know that speed is equal to distance divided by time. So we can answer this question here, 3.2.2. They want you to calculate distance. Average speed. Average speed. I'm going to write speed. Speed is equal to distance divided by the total time. Alright, so what is the distance? Is 200. What is the time? In the question they say that it took 1 minute. You cannot work in minutes. So the time will be 1 times 60, because it is 60 seconds. We have to work in seconds. So speed is equal to 3,33 meters per second. That is the speed. Remember, speed is a scalar quantity, so no direction needed. That is the answer for that question. And if you do that, you get 3 marks. 1 for the formula, 1 for the substitution, and 1 for the final answer. Quite simple. Jane started warming up at C. So now we're speaking from C. Let me erase this line, we don't need it. This new person called Jane started at a point C. He jogged to position E and then ran to A. So this person, let's identify here, starts here at C. It moved first to E, and then it moved to A. Alright, so this here, for instance, let's say is position 2. This one is initial position, for example. This one is position 2. This one is final position. It's in different places there, and this we're going to need it just now. Yes, use vector scale diagrams to represent the displacement of Jane. Show all the relevant information, and they say 1 centimeter to 10 Newton. Okay, so here is what we have. Here is what we have. Where the displacement will be. The displacement will be from position 1, from the initial position to the final position. So this one here will be the displacement. Now we have to do this one accurately, and we do have the questions here. It's 50 meters from C to E, and then from E to A is 100. So let's do the vector diagram here, the heading vectors graphically here. So this one is question 3.3.1. Let's write data first. Okay, so let's write here position 1 of displacement 1, it doesn't really matter. Let's say position 1 is equal to 50 meters. We're going to call position 1 this one here. This one is position 1. Alright, that is position 1 is equal to 50 meters. The scale is 10 meters, therefore we have to represent 5 centimeters. Okay, the second position, position 2, for example, let's say it is going to be from E to A, the long one. Okay, let's call this one position 2, the whole long one from E to A. Okay, and that one is 100 meters. This one, in other words, will be 10 centimeters. And then the displacement, we're supposed to get it here. The displacement is going to be from C to A, which is another 50 meters. This one is 50 meters and it's going to be 5 centimeters. So how we draw this one? We are going to start at point C. So let's say, for instance, this point here is C. Now for this one, remember, you do need a ruler. Please, I don't have a ruler. And then we are going to draw the first one. This one here is to the right. This one is left. And this one is left. So the first is 5 centimeters to the right, starting from C. So you take your ruler and you make sure you have 5 centimeters to the right. And this one, guys, is position 1. Alright, we're going to call it position 1, which is equal to 50 meters. Alright, now right on the head of this, right here on the head, I'm going to draw the next vector. The next vector is going to be position 2, and position 2 is 100 meters to the left. So started from here, we're going to take the ruler and measure 10 centimeters all the way to the left. This one here is position 2, which is equal to 100 meters. Then I draw another dotted line on the head of that vector. So here is another dotted line. And then the displacement is going to be the vector that is going from the tail of the first one to the head of the last one. So this one here is going to be the displacement. When you measure with your ruler, if you did it accurately, you should get that this one is 50 meters, which is equivalent to 5 centimeters, okay? And this is the question. Then you will have one for each vector, including the direction, to make sure all the directions are correct. There's one mark for direction. And that is all. That is all in terms of drawing that vector diagram. Biyana ran from C to D and back to C. So C to D and then C again. C to D. Let's see where it is. C, D. Where am I? C, D and then to C. So C, D, C. Okay? And they're giving you some numbers there. All right. And then from C to E in 1,5 minutes. Okay, so let's start here. Now, for the velocity. Velocity is not the same as distance. Velocity is a vector quantity. So let's write it here. The average velocity is a vector. It has a direction. That is the first important thing. Second important thing, velocity is equal to displacement divided by time. Not distance, but displacement. And I'm going to erase all these lines because I don't want confusion here. I hope you watch the video so you know what those lines represent. Okay, so now this person start initial position here. It go to D, come back to C, run to, read quickly here. Yes, I see now. Person ran from C to D, D to C, C to E. So the final position is going to be E. It started at C, it doesn't matter the path taken, that one was for distance, and the displacement will be from the initial position to the final position. In other words, this one here is going to be the displacement. Nothing to say. We don't have to stress about that. The displacement is 50 meters to the right. So this one is equal to, velocity will be equal to 50 because that is the displacement divided by the time, which is 1,5 minutes. Remember, you cannot work in minutes, so it's 1,5 times 60 to convert to seconds, and then the velocity, which remember it is a vector quantity, will be 0,056 meters per second, and we need to give a direction because we're calculating velocity. The question says calculate Brian's average velocity. So velocity, I'm going to write to the right. We need a direction. All right, if you don't want to write to the right, we're going to write towards E. The direction is towards E. That is the correct answer with the direction. You need a direction because it's a vector quantity. All you need to know is that the displacement is only 50. So we're going to give 1, 2, 3, and 4 marks. The displacement is 50. It's from starting point to ending point. And this one is the question on the motion in one dimension. Is quite simple. Next time we're going to solving this question here. This question here have to do with investigative question. It's good because we have to draw a graph and there is problems with the graph. Don't miss that video. I'll see you next time. I hope it helps. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.